CropEBal is a program that can be used to calculate the energy use in agricultural operations. We are going to download the English version from the web page at the University of Córdoba. We right-click, save link as, and then we can put the program in any folder of our hard drive with any name. Click on save, and then we go to that drive. To run the program, we just double-click on it, and then it may give us advice about, we will say run anyway. If there is any advice by the antivirus program, then the first thing that we need to do is to add the crops in the rotation. We're gonna run a rotation of wheat. We write double H during wheat. Then we add it to the rotation. We're gonna be irrigating, and we're going to produce 6,000 kilograms. Now we're gonna do the rotation with sunflower for oil. We add it to the rotation, and the sunflower is gonna produce 4 tons per hectare. We're not burning residues, and these are the amounts of seeds that we are going to use. We have a clay loam soil, and we'll be irrigating using a pivot system. We don't desalinize the water, and the pump has a electric motor. The pumping depth is 120 meters. The pump efficiency, the default is 70. We could change this. And now the tractor is a 2-wheel drive run with diesel. We click on proceed, and then first thing that we need for the first crop in the rotation is to add the tillage operations. This would start after harvesting the sunflower. We will apply a moldboard plow, and then we will apply, in this case we could change the depth. Then we will apply this harrow tandem for secondary tillage, 2 operations, and then a field cultivator for secondary tillage. Finally, we will sow the wheat crop using a grain drill with press wheels. We click on the following, and now for the wheat crop we'll be applying fertilizers. Before planting, we would apply one operation, and we will have 2 applications as top dressing. So we click on fertilizer spreader, and then we will have a total of 3 applications. We will also apply pesticides, mainly fungicides, with a boom type sprayer twice during the growing season. Finally, we will harvest using a combine for small grains self-propel SP. Now, if we have additional requirements of labor we don't have, we are not going to dry the harvested product, and our labor needs to travel 20 kilometers to reach the farm. We assume that we have 1 ton of inputs per hectare, including fertilizers, including pesticides, etc. So we are moving 1 ton, and the inputs are going to come from 20 kilometers distance. We click here, and that adds a total of 20 kilometers per tons per hectare. Now, after harvest, the grain will be transported to a facility which is 50 kilometers from the farm. Now we click on the following crop, and we have the sunflower. For the sunflower, we started by applying moldboard plow after harvesting the wheat, and then this harrow offset for secondary tillage, 2 operations, and finally a field cultivator for secondary tillage. Then we would be sowing using a row crop drill prepared over a prepared seedbed. a mounted machine. We click on proceed. In this case, we will only apply fertilizers before sowing, so only one application. We will not be applying any pesticides, and then we will use a combine for row crops. We don't have additional labor requirements, and the labor also comes from a distance of 20 kilometers. The amount of inputs is smaller, so let's consider that it's only 500 kilograms per hectare, and the distance is the same. We click here, and that sums the total tons per kilometer per hectare. The grain is transported 50 kilometers away from the farm. Now, after proceed, we will have here a summary of the materials used in crop production for that rotation. We have values of nitrogen fertilizer, P fertilizer, and K fertilizer suggested by the program according to the export of nutrients from this farm. Here we need to add the amounts of irrigation applied. Let's assume that it's 1500 cubic meters per hectare for wheat and 2500 for sunflower. Pesticides, we will apply 3 kilograms per hectare of active ingredient in the wheat, but not in sunflower. We leave the other data as they are. Now, after proceed, we will get the results of the calculations of energy expenses in the different operations and materials. For irrigation, we are applying this is the average for the rotation, and these are the values for each of the crops in the rotation. More than 8,000 megajoules per hectare are spent in irrigation as average for the rotation. Fertilizers, more than 10,000. Very small amounts for the applications of fertilizers, or for seeds, or for the operation of sowing. Tillage is also an important component, and also harvest. Pesticide application and pesticides are a minor component, but there is a significant expense in transport for the harvested product. The other components are small. Here in this column we have the output of energy in harvested materials and in residues. For sunflower, the residues are stay in the field, but for wheat they are exported. Now we have the total inputs of energy, more than 25,000 as average in the rotation, 25,000 megajoules per hectare, and a total output of energy of 154,000 megajoules. The ratio of output and input is rather high, and the energy used per kilogram of product is between 4 and 6 for the two crops in the rotations. If we click and show results, we open the txt file that is created in the same directory where the program is. So we can see all the calculations, all the inputs that we have introduced, and the results given by the program. In info, we have access to data on the sources used and the people involved in this project. Also, in info, we can access the manual for the program, and we can also access the reading material that are some chapters of our book. Clicking here, we exit the program.